Hello everyone, welcome to another new game. I feel like we've had several of these in the last week or so. You know, I find myself with some time on my hands, so here we are. This is called SIC-1, SIC-1. I don't know a lot about this game. I saw Steam pointing out that, or maybe it was Discord was pointing out that a friend of mine was playing this, and I checked it out. And it's also free, so like, sure, let's try it. It sounds like it could be interesting. It's a programming puzzle game, where as far as I can tell, the central gimmick is that it's like an assembly programming kind of thing, but there's only one instruction, which is powerful enough to do all the things you could want to do if you abuse it in various ways, I guess. And there's this whole, like, you know, so that's basically what I know. I read in the Steam reviews that at some point self-modifying code is a thing that you can do as well. So, I don't know. So blah blah blah, six systems, and it's like, okay, some theming about how you're gonna start a job working for six systems. Fine. This is I've never seen this screen before, right? We're learning this all together. Oh no, we're gonna read the manual on camera. Is that what we're doing today? Okay. Hi Mary. Here's the human resources reference manual and a guide to the IDE. Okay. Hopefully I don't need that right away, but sure. I'll open manual in game. Okay, so this is the manual for the one instruction, apparently. Good. Okay. Programs are written with the sublic instruction, probably. Subtract less than or equal to, I guess. Probably. Sublic then. 3 bytes, A, B, and maybe C? Or why is C in brackets? We'll see. Oh, that's probably because it's a memory address? No, they're all memory addresses. Okay. Or labels. Okay. Memory addresses only go up to 255, so we have a small computer here. Or maybe there's some way to specify an offset separately? I don't know. Subtracts the value at B from A and stores the result at A. Okay, so it decreases A by B. If the result is less than or equal to 0, branch to C. Sure. If C is not specified, the address of the next instruction. I see. So if you don't say where to jump to, the default is jump to the next instruction. So you can not bother with the branching part. Okay. Built-in addresses. Maximum user modifiable address is 252. I see. And these are special bytes that or special addresses that do something. Okay. I see. 252 is the last normal memory byte, and after that are IO bytes, or addresses. So in is to read things, out is to write things, and halt is to stop the program. Okay. I don't need any examples. I understand this. Semicolon for comments. Custom labels at name colon. And it makes sense you could have a label that you could jump to, but it did mention that also A, B, and C could all be labels. I'm not sure what it would mean to have a label be A or B here, but I guess that's where we get to the self-modifying code thing. .data. Sets bytes to specific values at compile time. Okay, so we have a little bit more than sublic to work with. We can set up a data area. X is a signed byte. Okay, yes, in the normal range. How do I specify what addresses these are at? Maybe they go in between. Maybe like if I just write like 2 sublics and then data and then a sublic, the data goes in between them. Maybe. And I'm guessing that the sublics, it'll tell me soon, but the sublics each take up 3 bytes. So that's, I can know what address my stuff is at if I want to like modify it or something. Okay. Constants and variables. Combining with labels with the .data directive. Okay, this is sort of what I was asking about. Allows you to develop a system of constants and variables. At 0 is a data that says 0. Fine. Okay. Unconditional jumps. Yes, fine. Of course, that's obvious. Don't tell me how to loop. Okay, label offsets. Loop plus 1 refers to the second byte of the instruction pointed to by loop. Okay, or by the label, which in this case is loop. So the first byte, presumably, is loop plus 1. The second byte is... Does it say somewhere that... Yes, each one is 3 bytes, A, B, and C. So this, of course, takes up 0 bits because we know each instruction will be a subleak. And if you're executing it, it must be an instruction. So I understand how to loop, or at any rate, I'd like to figure it out myself. But what? Loop plus 1. So subtract 1 from this and store it here is what this would do? It doesn't look like a loop to me. Usually involving self-modifying code, it is useful to store the address associated with a label in a byte of memory. Okay, sure. Here's an example of how to set a byte of memory to the address of loop plus 1. Sure. But why do we need to do that? Why can't we just write at loop plus 1? Like, why can't we write this wherever we would write this? What's the difference? I guess the difference is... No. This is... Okay, I don't know yet. Possible to negate labels? By putting a minus. Okay, negates the address. Sure. Reflection example. Okay, we're gonna leave this advanced stuff for later. And just like, hopefully there's nothing important here. Alright, next task. Let's like solve a puzzle, shall we? Hopefully. Use subleak and input-output to negate and input an input and write it out. Okay, that's easy enough. What? I just read the manual. Why you gotta put this in here? Okay, get out of here. I don't need this in my source file. This is useful because I did not read this manual. Use control dot to compile, and then I guess step as in step and debug, and run to execute the program. Okay. So negate an input. So we could say at 0.data 0, right? And now we have a byte in memory whose value is 0. And then we could say subleak of at 0, oops, at 0 from at in. Except that's overwriting what 0 is. So let's say, I mean, which would be fine because we're going to abandon the program any minute now, but let's say at x. Wait a minute. How do I copy a value to somewhere? Oh, no, okay, that's fine. Data, 0, whatever. So what we can do then is Actually, I don't... Okay, this is... I don't know what I'm using X for, I guess. Subleak of @0 from @in. And now we've taken input, subtracted it from 0, and stored the result in 0. And we should just now... Wait a minute. And it mentioned that the out variable, when you read it, reads as 0. Oh, so the example program here was correct. Because what I've done now is I've stored minus input in 0. And if I now subtract minus input from out, I'll get the input, not the negated input. So actually we were just supposed to write out in, right? But I've now figured out why. Compilation error. Were they not called out and in? Menu. Manual. Oh, they have to be capital, huh? Okay. Okay, so I'm in the stepping debugger now. And here's our subleak, right? FE and FD, those are out and in. Yes, makes sense. I don't see anything at this address, but... Oh, I probably need to write halt, don't I? Or... No? Cycles executed 1, bytes read 5. Well done, we did it. Okay. Sure. Don Cooper says, welcome to the team. You're my manager. Shouldn't you have talked to me before I did the first job for the team? Ted and Fang, okay, so we'll never see them in real life. Rick is my skip level boss. Okay, weird thing to tell me about. Of course I should raise things with my manager before looping in Rick unless I'm worried about my manager. I'm implemented programs, yes. Sorry if I was unclear that you would not be paid during training. I quit. r/anti-work, here I come. Alright. Can I delete this? I don't know, next task, whatever. Use data and labels to loop, fine. Custom labels, yeah, I know, I read the manual. Don't spoil it. Okay. Alright, what am I supposed to do? I see. 3 times I'm meant to, or maybe forever, I don't know. I'm meant to do what I did in the last program, yeah? So... we can write @loop, that's fine. We need to figure out how to do an unconditional jump, right? Because what we want is just subleak of @in and @out. No, out and in, right? And if we were to just write @loop here, it actually looks correct, except that if the input is a negative value, we won't jump, right? So, out of curiosity, why? Hello? Oh, I hit stop. I meant to hit step, I see. So that's only a little bit correct. It was correct for the inputs they gave me. But if anyone had given me a negative input, it would have failed, which seems a little bit disappointing. Well done, you did something. Great, okay. Dan Cooper says he's gonna pay me. No, free pizzas. Haha, very funny. Ted, yes. Could I help you with your job? Come on, I'm new here. Just using a label that points to 0. Reset variable, okay. This is what I tried to do on puzzle 1, and it was not actually necessary. Stop. Okay, this is Ted's program. Maybe it's not spoiling to look at it. The dat, you mean .data. Okay. Do I need to make my window wider? Would that make you happy? By the way, I was shocked when I opened this game and I was like looking for the volume controls, and I mean maybe there are some in game. I haven't looked. That's fine. Presentation settings? There are. I just turned it way down in Windows, and yeah, that's fine. I was shocked though when I looked, and like this isn't like a SIC-1 program window or whatever. This is a Microsoft Edge web view. What the hell? Anyway, the only time Microsoft Edge ever runs on this computer is for this game, apparently. Oh, yeah, this is kind of what I was doing in my first program, sort of, right? Where I accidentally didn't negate the input. So, yeah, reset temp to 0. Okay, so wait a minute. What is this all about? Does it always jump there? I thought it only jumps sometimes. Oh, less than or equal to? Right. It's not if it's negative. If it's 0 or negative, it jumps. Okay. So, we want to read from in and put that into temp, I guess? Subtract that from temp, rather. So temp will be the negative of the input. Then we write to the output the negation of the input. So we've got back the output again. Then temp is subtracted from itself, and we go to loop. That all seems fine. Okay. Thanks for completing your training. I'm an engineer. Okay. Finalize compensation package described in the packet on my desk. Okay. Fang Li has some instructions for me on how to think about this. Addresses are numbers, labels are names, sublique is 3 bytes, data is bytes. Yes, I understood all this stuff. Can be instructive to see the resulting compiled bytes. Okay, sure, I agree that could be interesting. Let me use my hand to... Actually, let's just scroll up so I can't see the answers. I was going to cover the screen, but then you guys could see it. So what should this compile to? This will, I assume, start at memory address 0. So 0 is... I mean, I don't remember if out is... Oh, it says stored address 0, yeah. I don't remember if out is... What are all the maximum user addressable bytes? I mean... It goes up to 255, right? And there were 3 of them. Last was halt, which was 255. I believe in was before out. So in should be 253 and out should be 254. So this should be 254, 253, 3 is what that should decode to, right? 254, 253, 3. Yeah, okay. So I understand all this stuff. And then this next one is... What's it? This is address... 5? No, 6, right? Yeah, address 6 should have a 0 in it. So this should be 660? 660. Yeah, okay. No problem. What am I meant... Oh, no. Delete. I could title these, but since I'm not, like, aiming for leaderboard stuff yet, I'm just going to use untitled for all of them. Read 2 numbers and output their sum. Below is the solution to the previous task. Ah, okay. Okay, that's useful enough. Because this is how I... This is how to read one number and output it, but I have to do more than that. Wait. In 1, expected 2? What does this mean? What? I don't understand this test at all. Oh, I see. No, I don't see. What? Oh, it shows you your labeled values. That's nice. I mean, I understand the instructions. I don't understand how this is any kind of codification of the instructions. Huh. Well, okay, maybe we'll just implement the program and see if this starts making any sense. So, we need to have a value that starts at 0, subtract from it twice, and then send that to the output. And then overwrite the thing, right? So this doesn't seem that hard. Let's call this X though, not temp, shall we? I don't know, maybe we can call it sum or whatever, but... So subtract from X, add in, and then just do that again, right? Take that and write it to out. Oops. I don't need any stinking comments. This seems correct, yeah? Yeah, okay, so if I say compile, step, what is this all about? Oh, I see. This isn't a table. The rows aren't correlated to each other. It's saying here are the 10 inputs you'll be given in order, and here's the 5 outputs you'll be given in order, and the 5 output that we expect you to make, and here's what you actually wrote. But like the second row of output has no correlation at all with the second row of input in general. I see. Okay, well, this all seems great. Well done. Yes. Checking in. How's it feel to be an employee? Cool. The cutting edge of revolutionary technology. Wow, only one instruction. Question about compensation. Yeah, okay, they're cheaping out on me. Talk to Rick. Uh-huh. Laying it on a little thick there. I wanted to share with you a little side project I've been working on. Sandbox mode. Okay, no thanks. Not now, anyway. Haven't implemented it. So read 2 numbers A and B, then subtract A from B. I mean, this is not that hard. Yeah, I mean, I guess I can... I don't know. Do I want a 0? Maybe. At data 0 doesn't even make any sense. That's not how this programming language works. All right. So we do want dot data. We were doing what? Add 0 of dot data 0 or something like that? Okay. So A minus B. So we need to let's just start them both as 0. That's probably helpful somehow. Subleak from into A from in. Subleak now it's a little funny because it's very tempting to immediately take A and negate it, right? I could say, for example, you know, if I wanted to, 0 at A, and then I would have in the memory address labeled 0, I would have positive A instead of negative A, right? And since we want a positive A and we want to subtract, it seems nice to have a positive A lying around, doesn't it? But since everything is negated when we output it, it's more useful to keep a minus A around, right? To compute B minus A and then output its negation. So I don't think we actually want to do this. Let's store into B another input, right? Something weird's going on with my audio-video cable. Or just my audio cable, I guess. I don't have a video cable. I'm sure it sounds fine for you guys, but I keep hearing little crackling noises when I bump a wire. So we have minus A and minus B, right? And if I subtract minus A from minus B, then I'm really taking positive A and adding it to minus B. So I'll have A minus B, right? But that's the opposite, which is what I want, but I'll have to negate it. So I should be subtracting B from A here, right? Oops. So now we had minus A, and we've added B to it. And if we subtract all of this from 0, then we should get the right output. And we just have to reset A and B. Also, I'm not using 0, I guess. How's that look? Everybody's happy. Okay. Well done. Now, it's showing me these graphs. I don't know who I'm being compared to. My friends? Sure, but none of them play. Not any Steam friends, anyway. Oh, no, there are... Okay. If I mouse over, does it tell me? No. But these look like... Can you guys see these tooltips, by the way? Let's see. It's a little hard for me to tell. No, you can't see the tooltips. Okay. If I were doing display capture, you could, but I'm, like, philosophically opposed to that. So, a score of... So this is how almost everyone in the world does it, I guess. 671 people got a score of 28. And 16 people got a score of 20. So cutting the time almost by a third. Well, by more than a third, almost by a quarter. And then there's a very small number of people who also read fewer bytes. I'm not even sure what it means to read fewer bytes. Does that include every time you read a byte from the memory? It must, right? Because if it were just how many times you read a byte from the input, they would all be the same, because everyone has to read each input byte exactly once. So, I mean, is there anything I can think of in here that looks redundant? We obviously have to read both inputs. That's sort of mandatory. I mean, there should be a 2-byte sequence we can, or a 2 instruction sequence we can drop, right? Because I have, well, hang on. There are 5 inputs. I had a cycle score of what again? 28 cycles. Which means, I mean, these last 2 didn't actually get executed for the last step, so it would be 30. But any one of these instructions I can trim out would save me 5, right? And any one of these instructions I could trim out would save me 4. Because they don't run on the very last cycle or input. And I'm supposed to save 8 somehow, which suggests I would save both of these, no? That seems very unlikely. Because A and B are both leftovers from the last execution of the program. Oh, I see. If you were to optimize for cycles, you wouldn't write a loop at all. You would unroll it, right? And just execute the same commands 5 times for different memory addresses. Is that what people are doing? Let me try to confirm that. If that's the way it is, I'm not going to try to compete with these people in general, but I want to understand if I'm missing something more interesting. So we can just say like A1, A2, or B1 and A1, right? 2, 3, 3, 4, 4, 5, 5. I like the, that's 6. I like the, was it test 100? One of these things had a way to like expand something n times as like a macro. That was kind of nice. And I think it could even refer to the loop count in the expansion. So anyway, if we went to @loop here. No, we're not looping anymore. Hang on, something's wrong here. No, it's not. 4 times 5 is 20, that's what we expect. So if we just take this and then throw in all the ones, 1, 1, oops, 1, 1, 1, 1, 1, 1. Or no, these are supposed to be 2s now, you dummy. Put in 3s. Those are supposed to have been 4s. You get so into like the swing of things, you forget you're supposed to use something different. This one should be 5. So I believe this is what people were doing to shave off the cycles, right? Yeah. That's a disappointing solution. Because it's just loop unrolling and it only works exactly 5 times. I don't think this is actually a solution to the task, and I don't think the game, like, quote, should allow it. I think, you know, they can't simulate arbitrarily many, they can't simulate you running this 1 billion times, but they should simulate it running like 200 times, so that you can't just fill up all your memory with garbage to do the first 5 times faster. Okay, and so if we went back here, well, actually, is there like a save as or something so I can program inventory? Rename to unrolled. Okay. Now, can I just hit undo in here 1 billion times and get back a real program? Yeah. run this... Oh, but... Just delete my life. Program inventory. Now I think I've overwritten the unrolled one, right? Yeah, very funny. There's not some way to recover it? Whatever, who cares? I'm not... So is there, like, for minimizing bytes read, I'm a little bit... It's less obvious. You can't just unroll it, right? Instead of unrolling... Oh, but now I don't even... Okay. I don't know what other people did anymore because it's so... I mean, I guess it was 18, right? So you could shave off 4 bytes? Huh. Not sure. Ah, I see. And we're going through, like... Okay, no, leave my programs. Email. Good time to remind you, you can use labels for variables and constants. A label is just an address, yes, I know. If I want to be able to write out a 1, I can create a constant. But if you're subtracting from it, you'll want to negate it. Yes, I understand. So, sign. If it's negative, output a -1. If it's 0, output a 0. Okay, so we're implementing sign. Yes, sure. So one thing I could do... Well, let's say loop. We're probably gonna need that, right? And we want a subleak from. I mean, let's just say at 0. I don't know. Data 0. We probably want that. So subleak into 0. I know it's not 0 anymore. Sad. From input, right? And if the result is less than or equal to 0, let's jump to at leak, right? I'll say at leak is some stuff. We'll write it later. If we didn't jump there, then it must have been greater than 0, yeah? So we can say subleak of into the output a -1. From at neg. So now we're subtracting -1 from the output, which means we'll be writing a +1. And go to at done, which probably seems like something we'll want. At done, subleak. Well, I'm not sure how much cleanup we're going to have to share between these things. Let's see. So we'll leave done for later, I guess. And we'll assume that it resets everything that needs to be reset and then goes back to loop. So we've handled the greater than 0 case now, assuming we finish writing done. If it was less than or equal to 0, then we need to figure out whether it was 0 or less than 0. How do I do this? I guess I subtract it from 0 again? I need another 0 to do that, because the one that I labeled 0. Let's call this... Oops. Well, that's fine. Neg x, maybe? Neg x, which starts at 0, of course. Then we'll put another 0 here. I know this could all be one data section. I could refer to it with loop label offsets, but that sounds horrible. So now we can say subleak into subleak from 0 the neg x, right? And if this is less than or equal to 0, then negative x is less than or equal to 0, which means x is either positive or 0. But we already know it's not positive because we tested that. We already handled that case here. So we'll go with eq. If that didn't happen, then our number is negative. And we need like 0 minus negative? No. That's how we get a positive, right? Let's just write, I don't know, add pos, why not? Data 1. Then we can say sub leak at pos, no, at out of at pos, and go to at done again, right? Now, if it was neither 0 nor, it was neither positive nor 0. Wait. Right, and now we have to define at eq, which is when we got a 0. But that's easy. We can just subleak from out and out and out and out, right? Because we just need to output a 0, and that's what we'll read there. So, how many of these values do we need to replace? We definitely need to overwrite neg x, and that might be it, right? So let's clean neg x. Subleak neg x, and that might, if that's the only thing we need to do, we can go back to loop. If we got here, we need to clean up 0 as well, right? Clean 0. Probably could say clean 0, but whatever. So if we say at clean 0, subleak of 0, 0, and it'll carry on to clean neg x. And I think those are the only two things we ever overwrite, yeah? So this should be it? Am I using all of these bytes? I am, right? Where's neg? There it is. Pause. Okay. So let's just run this and see what happens. Okay, wrong already. Good. Why? I wrote a 1 instead of a -1. What? No, yeah, if less than 0, I'll put a -1. If 0, I'll put 0, otherwise I'll put 1. Okay, so I did get this wrong. All right, so let's try this again. Subtract from 0 the input. Was the result less than or equal to 0? Okay, maybe I don't understand how the conditional jump works again. Manual. If the result of the subtraction is less than or equal to 0, it branches. Okay, I mean, that's what I thought. So why is what I did not what I meant to do? Oh, because I did a subtraction I forgot about? Because now if... Okay, I think these are backward. I mean, they must be, right? If the result of subtracting from 0 was negative, then this must actually be positive or equal, right? Must be positive. Again, or equal, which is fine. Yeah. But if I look at leak, really it should say geek now that we know what this is all about. Greater than or equal to 0. If we didn't get there, then we know the input was actually negative. So this should really be a 1. And we should subtract 1 from output. Right. And instead of pos, we have neg now. Is that all I needed to change? No. Why did it stop here? I guess because the last instruction was a bad one. We wrote a 0 when we should have written a 1. So how do I... Is there a good way to step until a specific input case? I don't know. So here, we're... Oh, I went too far there? Stop! Oh, I am allowed to keep stepping if I want. Interesting. So, compile... Okay, how's my data looking? The values are all fine. Okay. So it's not like I forgot to reset something, I think. We've just read into neg x -1? Oh, are we on... Okay. This is not what we just read. It's what we're going to read next, I guess. Yes. Oh, did I output twice for the same value or something? What's happening? Oh, I see. This is not an unconditional jump, right? Yes. Well, wait, isn't that fine? No, it's not fine. The problem is that we read this 1 and then output it and then assumed that we would be jumping to clean 0, but we didn't. We fell through to saying they were equal and we output a 0. I understand the problem. What is the solution? I mean, probably it's to insert an unconditional jump here because we know in this case we'll be subtracting -1 from 0 and the result will be positive and therefore we'll never jump anywhere from here. So we must do a cleanup here. So can I then not... Because this wanted to jump where? Clean 0. So in fact, I can just take this and clean 0 myself and jump to clean neg x. Right? Because we have to do some, like, subtraction yielding a 0 in order to branch, and it might as well be the one that that we need to do anyway. Yes. Interesting that I read fewer bytes than the average, although not by a lot, and had more cycles than the average, although again, not by a lot. So, what are people doing? They're getting 24. 24 cycles. And 30 bytes. 3 more than me. And also 3 fewer cycles than me. Huh. Well, okay, I guess that's fine. 3 is just a weird number when there's like... Well, I was going to say when there's 7 inputs, shouldn't you be doing like multiples of 7? But of course each input doesn't take the same number of instructions. Okay, we can at least call this to done. Or stop. Rename this to done, because we're like, yes, we are cleaning regex, but it's kind of our only cleanup step. I don't know. I like this program. It seems good. Oh, although... No. I was thinking maybe the instruction here could avoid going down to done and just do its own cleanup on the way out, like Geek does. But it can't because it's conditionally branching. So, I don't know. This seems fine. We'll just run it again to re-enter that in the books and get out of here. Really stuck. Do you have time to look at a multiplication task? Asked Fang, but he said run a loop, you idiot. Ted's a little clueless, huh? Read the non-negative numbers, 2 non-negative numbers, and output their product. Repeat. Okay, sure. We can do that tomorrow. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.